You might recognize the setup I've got here as the one we used in class when we were figuring out how to generate a velocity time graph. We had this little cart that could travel down the lab bench, and we knew how far it got because of this thing here, which is called a motion detector. It works by echolocation. It takes less time for sound to go here and back to the sensor than it does to go here and back to the sensor. So the computer has a pretty good idea of where the cart is. I wanted to use it to talk about a little force that you're probably aware of called friction. And I want to do 3 runs of this cart. I'm going to push it medium, then hard, then soft. And we're going to see what the graphs look like. So we'll start by doing it like I did in class, kind of a medium push. So, if you look at that, it looks pretty linear. We have this period from 0 to about 1.2 seconds where there's no change in its position, and that's when it was at rest before I gave it a push. From about 4 seconds onward, it was at rest again when it hit the books. We got this period here with a fairly linear slope, although it's curving a little tiny bit. We'll talk about that curve in a minute. I'm going to repeat it with a hard push. I want you to predict what shape that graph will have. So, I hope that's what you expected. The amount of time it was sitting still was about the same. That was my reaction time in order to push it. That's not important. The key thing is that the slope is much steeper. It got to its final position a lot more rapidly because it was going faster. Final position was the same because the stack of books at the end was in pretty much the same place. I'm going to give it a very mild push now. I want you to predict what that might look like. So, I mean, the most important thing is that it never got there. It's still not all the way to the books. But unlike this graph, which looks almost completely linear when it had a high speed, and this graph, which looks very nearly linear when it had a medium speed, this one has a broad, gradual curve. It's steep at the beginning, or steeper at least, to indicate faster speed. The speed is gradually decreasing. Why is that? You probably are aware of a force called the force of friction, which opposes motion. It has to do when surfaces rub on each other. This cart is actually a very low friction cart. It's got 3 wheels and surprisingly low friction. There's good ball bearings there. But there is some. Frictional force is a constant force. It was present for all 3 of the pushes at about the same rate. But this one would have had to go a lot longer before we started to notice the effect. It had such great initial velocity that although there was a change in it, we wouldn't have noticed it unless we had it go for a while. The other pushes, less initial velocity, the effects were more noticeable. It was greatly noticeable here.